Have you ever wondered what might be hidden in the far reaches of our solar system, just waiting to be discovered? Maybe icy planets, distant moons, or even forms of life beyond our understanding. It's intriguing, but while most people still think intelligent life is confined to Earth, new missions from NASA and ESA are set to show us a very different scenario. The Europa Clipper mission, combined with JUICE, promises an investigation that could transform what we know about extraterrestrial life, taking us directly into the ice and depths of Europa and Ganymede, moons of Jupiter. These mysterious regions, under the lens of the most advanced probes we've ever created, have secrets to reveal, and the possibility of life there is no longer just fiction. For a long time, the idea of aliens and intelligent life has been confined to movies and science fiction. But what few people realize is that we are now closer than ever to understanding if life could actually exist beneath the ice of moons like Europa. And the best part? This discovery is happening right now, right before our eyes, challenging everything we believe about what it means to be alive in outer space. Get ready for a journey that's not only scientific but almost philosophical. After all, if we do find signs of life there, will we still be the only ones? In a visionary leap that only minds like Arthur C. Clarke could make, the idea of life in unlikely places in the solar system was already brewing in his work. In 2010, Odyssey 2, Clarke imagined the moon Europa as a region full of mysteries and possibly inhabited by intelligent life. It's as if he foresaw what scientists today affirm with so much enthusiasm. This icy and distant world may hold secrets we've only just begun to uncover. For Clarke, outer space wasn't just empty space. It was fertile ground for what he believed to be humanity's next frontier. If you've ever dreamed of exploring the universe, think of how he did it with his mind, and today science is beginning to follow him. This vision of Clarke's has fueled scientists' and enthusiasts' imaginations for decades. He laid the foundation for us to see outer space not just as unexplored vastness but as a stage where life could emerge and thrive in ways we can hardly imagine. Think about it. How many movies, books, and even games are born from inspirations like his, from the dream of finding aliens or life forms on distant planets? Who knows, not too far in the future, you might see images of Europa and wonder what could be hiding beneath that ancient ice, never forgetting that Clarke had already envisioned it. Today, that seed of curiosity is nurtured by missions like Europa Clipper, set to explore this moon closely in an attempt, perhaps, to confirm what Clarke suggested. And it's curious, isn't it? In 2024, we're still connected to these ideas, now with cutting-edge technology, with probes and satellites sending signals from the solar system as if we were anglers seeking the big catch. Arthur C. Clarke didn't just uncover a piece of space. He seems to have thrown down a challenge to humanity. After all, who can resist the lure of unveiling the secrets of the universe, especially when it teases us with such fascinating possibilities? NASA's Europa Clipper mission marks a new chapter in the exploration of the solar system, bringing us closer to long-awaited answers about the possibility of intelligent life beyond Earth. Scheduled for launch in 2024, the Clipper is a probe designed with advanced technology to uncover the mysteries hidden under Europa's ice. This is no simple task. After all, Jupiter's moon isn't exactly the friendliest environment. With intense magnetism and extreme radiation, the outer space around Europa challenges even the most advanced equipment. But the Clipper has been built to withstand these obstacles, maintaining an orbit that minimizes damage and maximizes chances of success. For those closely following space exploration, the Europa Clipper mission is a true work of strategic engineering. Instead of a direct landing, the probe will make several careful approaches to Europa's surface, each time gathering crucial data on the atmosphere and the ice layers that cover what many believe to be a vast underground ocean. Just imagine the possibility of a huge saltwater mass churning beneath the crust of a moon of Jupiter. This isn't just a concept from science fiction, but an ongoing project that could soon offer concrete evidence of this mysterious reality. As Clipper moves closer to Europa, it's fair to say the whole world will be watching. Every piece of data collected will be meticulously analyzed, looking for signs of biological activity. And if we think about it, maybe the life forms there wouldn't be so different from what we know, or they might be completely unique. But one thing is certain. If the probe finds any clues, the search for life in outer space will never be the same. Clarke dreamed of this. Now, the Clipper is ready to investigate and, perhaps, answer questions that could change our understanding of the cosmos. Jupiter is not only the gas giant that dominates the solar system, it also boasts one of the most powerful magnetic fields among planets. This magnetic field is so intense it creates radiation belts that can fry electronic circuits in seconds, turning the orbit around it into a true minefield. The source of this power lies in a fascinating process. Jupiter's interior holds hydrogen in a liquid metallic state, a rare phenomenon that generates extreme magnetism. For any mission approaching the planet and its moons like Europa Clipper, this radiation is a constant enemy, requiring technology that can withstand an invisible attack from outer space. This challenge, although complicated, is part of the charm of exploring Europa and nearby moons. Imagine Clipper, a craft driven by the dream of unearthing a new world, facing radiation on all sides and still pushing forward. NASA engineers had to develop unique strategies, including carefully planned orbits that allow Clipper to gather data while avoiding the most intense radiation points. So, it's almost like a game of hide and seek, where each move is calculated and each approach is a victory against Jupiter's invisible forces. For us, observing from Earth, this battle against Jupiter's magnetic field is a reminder that outer space has its own rules. Even with all our technology, humans must still respect the limits imposed by these colossal forces. However, each adjustment, each carefully plotted orbit, brings us a little closer to what may be the grand prize. Understanding if, in the shadows of these titanic forces, life could exist in conditions that, at first glance, seem inhospitable. It's as if the universe itself is challenging us to discover what lies beyond the invisible barriers of radiation and magnetic fields. Europa holds fascinating secrets beneath its icy crust, and evidence of a vast underground ocean is becoming increasingly convincing. Imagine a saltwater ocean hidden, perhaps warmed by forces beyond sunlight and protected by a layer of ice as old as the solar system itself. The key to this discovery lies in the presence of an induced magnetic field, a telltale sign that scientists interpret as proof of a liquid, saline layer under the surface. And more. The unique formations and cracks stretching across Europa suggest ongoing geological activity, a sign that something is alive there, even if it's just the movement of water or ice in a constant cycle. To understand what this means, imagine planet Earth, with its tectonic plates and constantly moving waters. The idea that something similar might be happening on Europa completely changes our view of planets and moons in the solar system. The low number of craters on its surface indicates that Europa's ice renews itself, perhaps through a cycle where the underground waters rise and reshape the surface. This kind of frozen geology is something we're only beginning to understand but suggests a surprising level of activity for such a distant, cold place. These signs of an ocean also bring up an irresistible question. What might be living down there? In places on Earth with similar conditions, such as the deep oceans near hydrothermal vents, we find life adapted to extreme temperatures and pressures, surviving without sunlight. Maybe Europa hides something like this, a biosphere beneath kilometers of ice. The possibility of life on Europa doesn't stop at the presence of an ocean beneath the ice. The extreme conditions of the environment might actually favor the existence of microorganisms adapted to the harshness of outer space. Near Europa's surface, Jupiter's intense radiation triggers chemical reactions capable of generating molecules that could serve as food for potential life forms. This becomes even more interesting when we consider the effects of Jupiter's tidal forces on the Moon. They generate heat through friction, keeping the ocean liquid and possibly creating environments similar to the hydrothermal vents we have on Earth. When we look at the Earth's ocean depths, we find thriving ecosystems around these hydrothermal vents. In these areas, life flourishes without any need for sunlight, sustained by chemical reactions that support creatures adapted to conditions that, not long ago, were deemed too hostile for life. This reality offers a clue about what could be happening on Europa, where extreme conditions are not necessarily a hindrance but perhaps the starting point for alien life. It's as if the solar system itself conspires to create the perfect environment for life, even if in a different way. What makes this possibility even more intriguing is the idea that life may not be as rare as we once thought. If organisms can survive in ice, radiation, and darkness, who knows what else might be hiding in outer space? With Europa's extreme conditions favoring the generation of organic molecules, who's to say the next step won't be finding a form of life there that teaches us just how resilient life can be? The allure of discovery is almost irresistible, and the Europa Clipper mission takes us right to the heart of this mystery. When we talk about the potential for life in the solar system, we can't leave out Enceladus, one of Saturn's moons. Unlike Europa, which keeps its ocean well hidden under a thick crust, Enceladus displays plumes of water vapor and ice particles expelled from its surface, creating real geysers in outer space. These jets not only show that liquid water exists there, but also make it easier to collect samples for future missions, giving us a glimpse of how life might survive in such a hostile and remote environment. Europa, however, has an advantage. Its ocean is believed to have existed for much longer, offering a longer window for life to evolve. Comparing the two moons, we see that both Europa and Enceladus present favorable conditions for the existence of life, but in different ways. On Enceladus, we have more direct contact with what might lie beneath the surface, while Europa's thick ice layer suggests a more protected ocean that could shelter life without direct interference from space radiation. It's like choosing between two different environments. One more exposed, with easy access, and another more isolated, but possibly more stable. In a scenario of space exploration, both offer unique advantages and, at the same time, limitations. These comparisons lead scientists to an intriguing question. Which of the two moons would be more suitable to host potential life? Enceladus is a brilliant example of the variety of water worlds in the solar system, while Europa, with its potential of an untouched ocean, could be showing us a different side of how life could evolve. In both cases, scientists find themselves at a true cosmic crossroads. Perhaps, by investigating both, we may discover that life is more common than we thought, or even understand that each environment creates a completely unique type of life. The Europa Clipper mission won't be alone in its journey to Jupiter's system. In a historic collaboration, the European Space Agency, ESA, is also launching its own mission, called JUICE, focused on Ganymede, another of Jupiter's moons. The union of these two missions creates a unique opportunity to study the environment around Jupiter, capturing information that would be impossible for a single mission alone. It's like two research teams joining forces on an expedition to a new continent, each exploring a different territory but sharing data that enhances our understanding of the whole. This synergy could open doors to even more significant discoveries about life and extreme conditions in outer space. The JUICE mission is designed to gather specific data about Ganymede, while the Europa Clipper delves into the mysteries of Europa. Both missions will be exchanging information continuously, allowing scientists to compare the environments of these very different moons and perhaps understand how Jupiter's system influenced the evolution of each one. It's a collaboration that reminds us how, here on Earth, knowledge sharing between scientists from different fields leads to surprising discoveries. In this case, however, the ultimate goal is to find out if these frozen worlds can host life, even if it's in forms we've never imagined. What's fascinating about this partnership is the idea that, by joining forces, these missions have an expanded potential to capture valuable data about the solar system and perhaps even about the origin of life itself. With Clipper and JUICE sharing data, each discovery made on one of these moons can be compared and contrasted with the others. And, of course, there's the bonus of cross-continental synergy, with the best minds from NASA and ESA working together in a true space alliance. This dual mission reminds us that when it comes to space exploration, no one has to explore the cosmos alone. It's a global adventure, with the entire universe as its destination. So, are you ready to open your mind to the vastness of the solar system? Imagine applying everything we've learned about Europa, Ganymede, and the possibilities of extraterrestrial life, reflecting on how it redefines our existence here on Earth. If life can thrive in extreme conditions, why not challenge ourselves to seek out our own unexplored potential? This new era of space discoveries isn't just about what's out there, but about reinventing ourselves within. Think about it. If the next big revelation is within our reach, waiting for our curiosity and courage to explore. Now, be a part of this journey. Subscribe to the channel, activate notifications, and stay updated on everything that's coming. After all, each new discovery is an opportunity to expand our understanding of the universe and of ourselves. Shall we explore the unknown together?